Administration Education Bureau in collaboration with Addis Media Network. I'm Teacher Mamu. Today we will learn about another solid figures and their measurements. Okay, so before I proceed to the present lesson, I want to remind you some of the points that we have seen in the previous lesson. Well, in our previous lesson, we have discussed about pyramid, the terminologies associated with pyramid, and the measurements on pyramid. Okay, just to remind you what the formulas are, the lateral surface area of a pyramid is given by the formula half of the perimeter of the base times the slant height. Okay, we have derived this formula and we have seen examples related to this. Okay, this is the lateral surface area, and the total surface area of a pyramid is given by the formula, the lateral surface area plus area of the base. Okay, so you can rewrite this thing in the form half of the perimeter of the base times L plus area of the base, and the area of the base can be calculated depending on the nature of the base. If it is a square, you can multiply the side by side. If it is simply a rectangle, you can use a rectangle formula. If it is triangular, you can use a formula of area of triangle, right? So we can simply put the formula for the formula of total surface area by the lateral surface area plus area of the base. Okay, so this is the second formula that we have seen, and the third one is the volume of a pyramid. Do you remember what the volume of a pyramid looks like? Do you remember its formula? Well, the formula for a volume of a pyramid is 1/3 of area of the base times the height of the pyramid. Okay, this height is the altitude of a pyramid. Okay, you need to differentiate the slant height and the height. Okay, the slant height is a height for the lateral face, and this h is the altitude drawn from the vertex to the center of the base. Okay, so this is the formula that we use to calculate the volume of a pyramid. Okay, so let's take a single example, then we proceed to the present lesson. Okay. If the volume of a square pyramid is 120 centimeter cube, and the height is 10 centimeter. Calculate the base edge. Calculate the base edge. Or the side of the square. Okay, in this example, what is given? A square pyramid is given. Okay, this pyramid has a volume 120 centimeter cube, and the height of the pyramid is 10 centimeter. So based on this information, you are asked to calculate the base edge, or one of the side of the base. Okay, to calculate the base edge, we directly apply the formula for the volume of a pyramid. Okay, the volume of the pyramid is equal to 1/3 of area of the base times h. We have the volume, which is 120 centimeter cube. This must be 1/3 of area of the base times the height is 10 centimeter. Okay, now to make things easier, divide both sides by 10. Okay, whenever you divide this thing by 10, over 10 over 10. This can be by 10 centimeter, okay? Make it 10 centimeter. So the left-hand side becomes 12 centimeter square. This is equal to 1/3 of area of the base. Now, multiply both sides by 3. This becomes, area of the base becomes 36 centimeter square. Now the question is calculating the base edge. Since the pyramid is a square pyramid, the base is a square. So if you say x is the side, then area of the base becomes x square. Okay, so this becomes x square is equal to 36 centimeter square. By the way, you don't need to sketch the pyramid. You can apply the concepts directly. Once you are familiar with the different terminologies, you may not need, it's okay if you sketch it, but it's not a must to sketch the pyramid to answer this thing. So you can represent x as one of the side of the base, then x squared becomes area of the square. So x squared is equal to 36 centimeter implies x is the square root of 36 centimeter square. Since 36 is a perfect square, you can take it out as 6, and centimeter can also be taken out. So this becomes 6 centimeter. Now this 6 centimeter is the base edge of the square pyramid. Okay, this is how we calculate measurements in pyramid. Okay, now we proceed to the next lesson, which is about a cone. Okay, today we discuss about a cone. Okay, as usual, before we proceed to the different properties and the measurements, we need to be familiar with the different terminologies on a cone. Okay, a cone is a solid figure having one base, as you can see here, and a vertex which is not lying on the base. Okay, so this is a cone. Here in cone we have a vertex. Okay, we have one vertex which is similar to a pyramid. We have a curved surface. We call it the lateral face. And we have a single base which is circular. And so we call it a circular cone because there are different types of cone. Based on the nature of the base, we call a circular cone if the base is circular. The other thing, there is also a radius which is drawn from any point on the circle to the center. And the height is a line joining the vertex to the center of the circle. Okay, so you need to understand what we mean by height. Okay, unless otherwise, unless it is specified as a slant height, whenever we say height, we mean to say that a line joining the vertex to the center. Okay, in this case, this segment can be considered as a slant height. Okay, what makes this cone similar to the previous solid figure is the feature of having a slant height and the normal height or the altitude. Okay, so we have height and slant height, radius, vertex, and lateral face, which is the curved portion of the solid figure. Okay, these are the terminologies that we will be using in the discussion of a cone. Now let's see surface area and volume of a cone. Because whenever we are discussing about the different solid figure, we need to first understand the terminologies, then the properties. After that, we need to apply measurements. Because knowing the measurements of different solid figure is very important in our daily life activities. Because whenever we go everywhere, we see different solid figures. We have different types of solid figures almost in all parts of our life experience. So it's good to know the different measurements in solid figure. So as usual, we will try to see the three measurements: the lateral surface area, the total surface area, and the volume of a cone. Okay, so the lateral surface area of a cone is given by half of the perimeter of the base times the slant height, which is the same as the formula that we used to calculate the pyramid. The difference is the base of a pyramid is polygonal, and here the base of a cone is non-polygonal, which is a circle. So this perimeter will be converted into circumference, half of the circumference, which is the total measure of the base, the periphery of the base, times slant height. Okay, this case, the slant height is similar for both cases. As you all know, the circumference of a circle is given by the formula 2 pi r. Okay, so in place of c, substitute 2 pi r. Okay, so there is L here, the slant height. So the whole this product gives us the lateral surface area. Okay, this can be simplified. Okay, 2 by 2 can be cancelled out. Therefore, the lateral surface area of a cone is given by the formula pi r L. Okay, so to calculate the lateral surface area, we need the radius, we need the slant height. Okay, the second one is the total surface area. As we have seen earlier, a cone has only one base. Okay, so whenever we are calculating the total surface area, we need to add the lateral surface area plus area of base. Okay, so AL, or the lateral surface area, is pi RL from the first formula, and area of the base. Now, since the base is circular, area of the base becomes area of a circle. And you all know that area of a circle is given by the formula pi r square. Okay, so the total surface area of a cone can be calculated by pi RL plus pi r. If you want, you can factor and write in a different way. Okay, here we have pi, we have r, here r is r times r. So you can write the total surface area in this form, pi r, then here it remains L, and here it becomes r. Okay, so this is the formula that we use to calculate the total surface area of a cone. The third one is the volume of a cone. The volume of a cone is given by the formula 1/3 of area of the base times h. Now here the base is circular, so you can apply the formula for area of a circle. So in place of AB, you can substitute pi r square times h. Okay, so we have three formulas here: volume of a cone and the surface areas, the two surface areas, the lateral and the total. So the volume of a cone is 1/3 of pi r square h. Okay, we need to know these three formulas to measure or to calculate the different measurements in a cone. It can be lateral, total, or the volume. Okay, so based on this formula, we will see different examples on measurements of a cone. Now let's see the first example. In this example, we are asked to calculate the lateral surface area, the total surface area, and the volume. Okay, we are asked to calculate these three things: the lateral surface area, the total surface area, and the volume of a cone whose base is circular, whose radius is 4. The height of the cone is 4 centimeters, and the slant height is 5 centimeters. here we have everything. Sometimes this slant height may not be given. Okay, usually the radius and the height is given. In this case, you need to be very technical. You have to consider the triangle and apply Pythagoras theorem, because always the altitude is perpendicular to the base. Okay, so let's go back to the question and calculate the lateral surface area first. So we said that the lateral surface area of a cone is given by pi r L. Okay, sometimes you may forget the formula. That's fine. You need to remember at least the lateral surface area is half of the perimeter times L, where this perimeter is the circumference. So in place of P, you can substitute to pi r and obtain this product, pi r L. Okay, so now let's directly substitute the radius and the slant height here. So this is pi times the radius is 3 centimeter, and the slant height, this L is the slant height. Okay, always I use to differentiate the slant height and the height of a pyramid by using the notation L for slant height and H for the altitude of the cone. Similarly for pyramids too. So L is here, L is the slant height, which is 5 centimeter. So this product gives us 15 pi centimeter square. Okay, if you want to know the approximate lateral surface area of this object, you can substitute 3.14. That is not the exact value, it's an approximate value, and multiply 3.14 by 15 to get the approximate value of the lateral surface area. Whenever we say this much is the lateral surface area, we are talking about the area of this curved surface. Okay, so the area of this curved surface is this much. The next one is the total surface area of, this cone is the sum of the lateral surface area plus area of the base. Okay, you can use the formula pi r into L plus r, but usually you may forget this formula. So you can directly use this concept as it is, the sum of the lateral surface area plus area of a base. So the lateral surface area is already obtained, which is 15 pi centimeter square, plus area of the base is circular, it's pi r square. So pi times r square. So the square of 3 centimeter is 9 centimeter square. So this becomes 15 pi centimeter square plus 9 pi centimeter square. Okay, the sum of these two becomes 24 pi centimeter square. Okay, this is the total surface area of the cone. That means the area of the curved part together with the area of the flat part, which is the circular part. Well, we are left with one more thing, which is about volume of the cone. So the volume of this cone becomes 1/3 of area of the base times the height of the cone, which is the altitude. Okay, this is H and this is L, the slant height and the altitude. So the base is circular, so we can write like pi times r square, which is 3 centimeter square, times the height, which is the perpendicular distance from the vertex, to the center of the base. Okay, so that height is 4 centimeter. Now 3 centimeter square is 9 centimeter square. Okay, 3 centimeter, the whole square means 9 centimeter square. So let's multiply everything here. 1/3 times pi times 9 centimeter square times 4 centimeter. You can simplify 9 by 3, the result is 3. Okay, 3 times 4 is 12. So we have also pi, so the whole this thing becomes 12 pi centimeter cube. Okay, this is the volume of the given cone. Okay, so now let's see the second example regarding the measurements on a cone. Okay, in the second example, it says find the lateral surface area, the total surface area, and the volume of a cone whose radius is 8 centimeter and height is 6 centimeter. Look, whenever we are doing measurements, we don't have any other thing except calculating the lateral surface area, the total surface area, and the volume. So in all the solid figure, you need to be familiar with calculating the lateral surface area, the total surface area, and the volume, right? So in this example, we are asked to calculate those three things. What is given, the radius of the cone is given, and the height of the cone is given. Okay, so the first thing that we are asked is the lateral surface area. Okay, so the lateral surface area of a cone is given by the formula pi r L. Okay, we have the radius, but we don't have the slant height. This height is the perpendicular drawn from the vertex to the center. So roughly, you can sketch it like this. If this is our cone, what is given, the height is given, which is 6 centimeter. Okay, the radius is given, which is 8 centimeter. Okay, so here we have only the radius and the height h. We don't have the slant height L. Okay, now considering the triangle, you can say this is A, O, B. Since this is OA is the altitude, it forms perpendicular at the center, so that you will have triangle AOB. Okay, triangle AOB is now a right angle triangle because it forms 90 at the center. If you have a right angle triangle, you can use Pythagoras theorem to determine the unknown third side. Okay, we have two known sides, h or 6 and 8. So we need to determine L by using Pythagoras theorem. So Pythagoras theorem tells us the square of the hypotenuse is equal to the sum of the square of the other two sides. So L square becomes 6 centimeter square plus 8 centimeter square. Okay, so this is 36 centimeter square plus 64 centimeter square. The sum of these two is 100 centimeter square. So L square is 100 centimeter square, means L is the square root of 100 centimeter square. So 100 is a perfect number. It can be taken out from radical because 100 is 10 square. So it can be taken out as 10. Centimeter square can be taken out as centimeter. So the slant height is 10 centimeter. So now we can calculate the lateral surface area of the cone. So substitute everything here. It becomes pi times the radius is 8 centimeter, and the slant height is already obtained, which is 10 centimeter. Okay, this product is 80, and we have also pi. 80 pi centimeter square is the lateral surface area of a certain unknown cone. Okay, we have got the answer for the first part. The next one is calculating the total surface area. Okay, so the total surface area is the sum of the lateral surface area plus area of the base. Here, AL, or the lateral surface area, is obtained, which is 80 pi centimeter square, plus area of the base. Since the base of a cone is circular, you can use area of a circle, the formula of area of a circle, which is pi times r square, which is 8 centimeter square. Okay, so 8 square is 64. We add 64 pi centimeter square with 80 pi. So its result becomes 144 pi centimeter square. This is the total surface area of the cone. And lastly, we are asked to calculate the volume of the cone. So the volume of the cone is given by the formula 1/3 of area of the base, okay, area of the base times the height. Now, area of the base is here. You can obtain this area of base from the second question, which is pi r squared, 64 pi. Okay, so you can use 1/3 of 64 pi centimeter squared times the height. The height is 6 centimeter. Okay, the height is 6 centimeter. Now you can multiply 6 by 1/3, it becomes 2, okay? 2 times 64 pi becomes 128 pi centimeter cube. This is the volume of the cone. Okay, now let's see the next example. Now let's go to the third example. It says, find the lateral surface area, the total surface area, and the volume of a cone whose radius is 7 centimeter and height 10 centimeter. I need you to work on this example. So take 1 minute to calculate the lateral surface area, the total surface area, and the volume of a cone, having the information that we have here. The radius is 7, the height is 10 centimeter. So calculate those three things. Well, I hope you have tried your answer. Let's compare your answer with my solution. Okay, so it says there is a cone whose radius is 7 and height is 10 centimeter. So you can roughly sketch the cone to identify the slant height. Okay, so here we have the height. Okay, we have a cone whose height is 10 centimeter. So you need to construct in this manner. Okay, your construction should be a line joining the vertex of a cone and the center, forming 90 degrees, right? So this is 10 centimeter. The other information that we have here is the radius is 7. Okay, so you can construct the radius like this, which is 7 centimeter. Okay, so to calculate the lateral surface area, you need to have the slant height. Okay, so without having the radius and the slant height, we cannot calculate the lateral surface area. So we will calculate the slant height by using this triangle. okay? Since the triangle forms 90 degree, it's appropriate to use Pythagoras theorem. Say this is L, okay? If you say this L will be the hypotenuse for the right angle triangle that we have constructed here. So L square is equal to 10 centimeter square plus 7 centimeter the whole square. Okay, so the first square is 100 centimeter square, and the next one is 49 centimeter square. So the sum of these two is 149 centimeter square. Okay, so the slant height becomes square root of 149 centimeter. This is not a perfect square, so you can put as it is, or you can use your calculator to obtain the approximate value of the slant height. Okay, approximately it's around 12 point something, but we don't need that approximation. You can directly take the slant height as it is. Okay, so we have now the slant height, which is radical 149 centimeter. So now we can calculate the lateral surface area. Okay, so the lateral surface area is the product of pi times r times l. Okay, so r is already 7. So you can substitute everything here. It becomes pi times 7 centimeter times radical 149 centimeter. So you can put this like 7 radical for 149 pi centimeter square. Okay, so this is the lateral surface area. I hope you got the same answer. The next one is the total surface area. The total surface area is given by the formula pi r into L plus r. Okay, or the sum of the lateral surface area and area of the base, which is pi r square. Okay, you can do like this. So if you are taking this in this way, you can write 7 radical 149 pi centimeter square plus r is 7. Okay, pi times 7 square. Okay, 7 centimeter square. So this is 49 pi. So it becomes 7 times 100 square root of 149 pi centimeter square plus 49 pi centimeter square. Okay, if you want, you can write this thing in another form by factoring something common in both. Okay, you can take 7 from here because 49 is 7 times 7. You can also take pi. Okay, if you said this is the total surface area, that's fine and it's correct. You may also write this thing like 7 times pi times radical 149 plus 7 centimeter square. Okay, you can also write this in this form. Okay, both of them are correct. So this is the total surface area of the given cone. And the last one is the volume of the cone. We are also asked to calculate the volume of the cone. So it becomes 1/3 of area of the base times h. Now, area of the base is area of a circle. So this is the same as 1/3 of pi times r is 7, square times the height. We use this height, which is 10 centimeter. Okay, so 7 square is 49. Okay, 49 centimeter square. You can multiply it by 10. It's 490 pi over 3. Okay, so this is 490 pi over 3 centimeter cube. Okay, this cannot be simplified by 3 so that you can put as it is. Hopefully you get the same answer. So this is how we calculate the lateral surface area, total surface area, and the volume of a cone. Good. Now let's see the last example that we have for today. In example 4, it says the height of a right circular cone is twice the radius of the base. Which one of the following is the volume of the cone in terms of its radius? Okay, so here what's given, the height of a right circular cone is twice the radius of the cone. This is a key information to calculate the volume of a cone in terms of R. Okay, so here the question is to represent the volume of a cone in terms of the radius. Okay, let's put this information properly. Now here it says the height of the cone is twice the radius of the base. So you can write h is equals to 2 times r. Okay, so the question is, what is the volume of this cone in terms of the radius? So this is how you do things. We all know that the volume of a cone is given by the formula 1/3 of pi r squared times h. That means 1/3 of area of the base times height. Okay, this is area of the base. Now, here in place of h, you can substitute 2 times r because of this statement. Okay, the height of the circular cone is twice the radius. So in place of h, substitute 2r, and this becomes 1/3 of pi r squared times 2r. Okay, so whenever we take this 2, it becomes 2/3 of pi r squared times r. What is the product of r squared and r? The product of r squared and r is r cubed. So this expression becomes 2/3 of pi r cubed. Okay, this is the volume of a cone in terms of the radius. So from the choice, we can find this thing in D. Okay, so the answer for this question is D. Okay, so this is how we calculate the different measurements in a cone. So in our today's lesson, we have seen what a cone looks like. And we have also seen the terminologies associated with a cone. Then after, we could see different measurements in a cone, like the lateral surface area, the total surface area, and the volume. Okay, so in all the discussion that we have seen so far, we were calculating the lateral surface area, the total surface area, and the volume. And this is the most common things in the discussion of the measurements of different solid figures. So I hope you enjoyed the lesson. This is all for today. Thank you for watching.